It's a good day, Metric. Welcome to another lesson in genetics. And this time we'll be looking at the blood types. Bloody types. Bloody types or blood groups. Okay. Remember, blood types is part of genetics. It's a continuation of genetics is from what has been done this far. Now, a blood groups, remember, they are determined by what we call multiple alleles. So blood groups are determined by multiple alleles. Now let's look at this word multiple. The word multi means many. Okay, the word multi means many. So what are multiple alleles? Multiple alleles, we say it's more than two alternative forms of a gene for a trait. Now, and then remember that this far what we've done, you must remember that for every characteristics that you've been discussing in monohybrid crossing, dihybrid crossing, we've been talking about there are two factors, two alleles for a characteristic. As Mendel actually indicated in his second law. In his second law, Mendel indicated that an organism has two factors for each characteristics, which actually segregate so that each gamete is going to have only one factor. So we are borrowing those words of Mendel now to apply this concept of blood groups. Now, multiple alleles are more than two alternative forms of a gene. What does this actually mean? It means that there are three alleles that determine blood groups. There are three alleles for blood type. I want you to get me very well here. In these alleles, i.e., we have I, A, I, B, and I recessive. So there are three alleles. These are the alleles that actually determine the blood group. Now, listen very carefully here. For me, as an individual, I need two alleles to give me my blood type, the particular blood type I have. Okay? You, as an individual, you need two alleles. I'm talking about an individual. So meaning that an individual has two alleles. An individual has two alleles. Two alleles for blood type. Now, in your family, you remember you are just an individual, but in your family, your family consists of many members, isn't it? So each member will have two alleles which determines his or her blood group. However, as a family ninonke, there are 3 alleles. So in a family, remember a family is a community. A family is a community. So in a family, there are 3 alleles for blood type. Okay, so meaning that these are the alleles. You're going to have IA, IB, and I recessive. But an individual has 2. Now let's look at this here. Think about your classroom. In your classroom, your classroom consists of many individuals. Maybe you are 30, or maybe you are 40, or you are 45. So in your family, there are 3 alleles that determine the blood group in a family. I'm not talking about an individual. Okay, so meaning that there can only be 2 alleles that combines. And remember, an individual receives 1 allele from each parent, 1 from the mother and 1 from the father. Okay, right. So an individual receive 1 allele for 1 allele, from the father, or let me say from paternal, and 1 from maternal, mother. So this is what actually happens, meaning that you receive 1 allele. Maybe you might have received this allele from your mother, and you receive this allele from your father. So these 2, they come together. Then you as an individual, you are going to have this combination of the genotype of your blood type, which in this case is going to blood type A. Now let's look at this here. If we can say that these alleles, the 3 alleles, which are multiple alleles, are to combine, then they can give us a combination of the following blood types. Okay, so I'll say genotype. I'll give the genotype here. Then here we're going to have the phenotype. These are the various combinations that you're going to have. So, which means that for blood type A, remember, blood types is the only cross where you use letters for phenotype. Let's say an individual who is IA. Remember, you need 2 alleles, isn't it? So this person is going to be blood type A. We use capital letter A. Then this individual blood type A can also be written like this: IA and the recessive I that way. Then it's going to still be blood type A. So for an individual who is IB dominant, is going to have blood type B. Or an individual can be IB, remember this is capital letter I, then I recessive. This individual is going to blood type B. Okay? So meaning that for blood type A, an individual can be homozygous, that's AA, kanje, or can be heterozygous. So this individual here is heterozygous. heterozygous, while the other one is homozygous. So very important. Nako nangala with IBI, this individual is also going to be heterozygous. While this one and this one, these two are going to be homozygous. This one also, they are going to be what? Homo. Remember the word homo means same. This is going to be homozygous. I was trying to indicate that. I'm just trying to break it down so that you can understand this in that way. Now, what about an individual who is going to be IAIB? IAIB, this individual is going to be blood type AB. Okay, so this individual, we normally say that this individual has blood type codominance, or we say is codominance. Codominance. Do you remember codominance in one of my lessons? Yeah, so this is the codominance because these two alleles are dominant. By the way, if I come back there, let's go back here. So this I and I are dominant. So these two here, these two, they are dominant. Okay. While this one here, the I recessive, is recessive. So each time this recessive allele combines with IA or IB, then the individual will carry the dominant allele characteristic. The recessive will not appear. It only appears if it is recessive. Two of them are recessive. So meaning that an individual for I recessive, this individual is going to be blood type O. So for blood type O, you need two recessive alleles. So this is the combination that you need to remember. So whenever you are doing a genetic cross, you must always use IA. The way I've actually displayed them, this will actually help you understand or do well. Okay, now let's look at an example of a genetic cross. Right, welcome back again. So let's look at this. Let's take it that an individual or a father, remember it's a P1 generation there, a father whose phenotype for blood group is blood type A homozygous. A who is homozygous, remember say it's homozygous. But you don't need to write homozygous, you just say blood type A. Marries a woman who is heterozygous blood type B. Heterozygous. So these terms are very important. So homozygous blood type A, homozygous blood type A and heterozygous blood type B. So what will be the cross like? So you remember the genetic cross, always follow that pattern. So the genotype will be IA because it's homozygous. Cross IBI because it's heterozygous. Right. So what does it give us? It gives us the gamete now. Or let me say this, sorry. We're going to have meiosis. Meiosis will okay here. These alleles are going to separate to form what? Gametes. So what do we have here? When meiosis occurs here, it's going to form 4 gametes, 2 from each parent. So you're going to have that IA, IA, IB, I recessive. When you cross this, it's going to give you, let me say this, we have fertilization there. This IA and IB there. You are going to have IA and IB. It can be IA and I recessive there. You're going to have IA, I recessive. Right? Then IA again and IB. You're going to have IA, IB. Then this IA and I recessive, you're going to have IA and I recessive. The way I've written, this gives us the genotype. Okay, so genotype then therefore will give us the what? The phenotype. Right, now let's check there. We got IAIB, IAI, recessive IAIB. You can see that we have got two IA2 as two IAB and IAIB. These two, they look similar, and these two, they look similar. So to minimize the work that you have to write, or to repeat what you have to write, you just say the phenotype. This one is blood type AB, and this one is AB as well. So I mean, 2 blood type AB is 2. These two are identical. They are similar there. So you're going to say these are going to be blood type A. How many are they? There are 2. Remember, there are 4 offsprings there. So it has to translate there to show you that there are 2 offsprings. There's a 2 plus 2. It gives us what? It gives us 4. So in this case, you have got 2 children with blood type AB and 2 children with blood type A. So this is going to be your F1 generation. This is going to be your F1 generation. If you don't mind, we can even actually pair it up. Then meiosis goes with fertilization. Then you are done. That is your genetic cross. Okay. So I want you to go through a question. Just choose a question from the past exam paper and see if you are able to do the correct thing. So that is about blood types. Okay. Thank you.